Hello friends, I welcome you in lecture number 39 on relations. In this lecture we are going to discuss one more question on finding the transitive closure of a relation. We have understood what is transitive closure of a relation in lecture number 38. We recall the method of finding transitive closure of a relation. Suppose R is a relation on a set A, then suppose set A has n elements, then transitive closure of relation R is given by union of R, R2, R3 and so on up to nth power of R, where this R2 is defined as composition of R with itself. Similarly, R3 is defined as composition of R2 with itself, and in general, suppose we are interested in nth power of R, then we consider composition of n minus 1th power with R. So with this in mind, we are going to discuss this question on finding the transitive closure of this relation. This question was asked in GTU Summer 2021 exam. Here we are having a set with 5 elements, and this R is defined on this set, that is R is a subset of A cross A, and as I discussed, the transitive closure of R is given by R plus equal to union of R, R2, R3, R4 and R5. Because set A has 5 elements, we are going up to 5th power of relation R. So we already have R on A, and we will start by finding R2. First we find out R2 by considering composition of R with itself. So that I have obtained here. To find out R composite R, I am writing relation R and composition of R with itself. I am writing this symbol for of composition. Now we know how to find out composition of two relations. We start with ordered pairs of first relation here. First we concentrate on this ordered pair 1, 2, and here second component is 2. So in this set we will search for that ordered pair whose first component is 2, and we can observe that there is no ordered pair here whose first component is 2. So now we come to the second ordered pair. Here second component is 4. So in this part we will search for that ordered pair whose first component is 4. So we can obtain here there are two ordered pairs having first component as 4. So if we combine these two ordered pairs 3, 4 and 4, 5, that is 3 related to 4 and 4 related to 5, then in the composition we will write first component as 3, second component as 5. So we have 3, 5 ordered pair in R2. Similarly, if we combine with this ordered pair, then we have 3, 4 belongs to R and 4, 1 belongs to R. So here we have ordered pair 3, 1 in the composition. So we have done our work for second ordered pair. Similarly, we have to check for each and every ordered pair of the first relation. Now we come for this ordered pair 4, 5, and we here second component is 5. So here we have to search for that ordered pair whose first component is 5, and we can see that there is no ordered pair having first component as 5. Now we move for this ordered pair. Here second component is 1, and here we have to search for those ordered pairs having first component as 1, and we obtain two ordered pairs. So if we combine these two, we have 4, 1 belongs to R and 1, 2 belongs to R. So we will write ordered pair 4, 2 in the composition. Similarly, if we combine these two, then 4, 1 belongs to R, 1, 1 belongs to R. Here first element is 4, here second element is 1. So we have ordered pair 4, 1 in the composition. And the last ordered pair we have to check is ordered pair 1, 1. So here also we have second component as 1, we can see for this ordered pair second component is 1. So again I have to concentrate on these two ordered pairs. If I combine these two, then I have 1 1 and 1 2. So I have to write ordered pair 1 comma 2 in the composition. And if I combine with this, I will have 1 1 and 1 1. So we can see ordered pair 1 1 is in the composition. So this is our R2, second power of R2, which we have obtained by taking composition of R with itself. In the next step, we have to find out third power of R, that we can obtain by taking composition of this R2 with relation R. This is relation R. So in the next step, we will consider composition of R2 and R. So that I have written here, R3 equal to R2 composite R. This is R2 that I have written from this step. I am writing R2 here, and our relation R is this one that I have written here. So now I have to consider composition of these two sets. This is R2 and this is R. So again I will start with each ordered pairs of this first set. If I start with ordered pair 3 5, then here second component is 5, and I have to search for this R. I have to search in this relation R for that ordered pair whose first component is 5, and there is no ordered pair having first component as 5. Now we come to this ordered pair 3 1. Here second component is 1, so I have to concentrate on those ordered pairs whose first component is 1. So I obtain two ordered pairs, here 3 1, and for this second component 1, I obtain this 1 2 and this ordered pair 1 1. So 3 1 belongs to R2, 1 2 belongs to R, and I have to write 3 2 in the R3. Similarly 3 1 belongs to R2, 1 1 belongs to R2, so I have to write 3 1 in R3. So we obtain 3 2 and 3 1. So that I have written here, ordered pair 3 2 and 3 1. So I have finished for this ordered pair 3 1. Now I concentrate on this ordered pair 4 2. Here second component is 2, and I have to search here for first component as 2, but there is no ordered pair whose first component is 2. And now I am coming here for ordered pair 4 1. I have to search for those ordered pairs whose first component are 1, and we have already written those two ordered pairs whose first component are 1. So that I have to combine with this ordered pair 4 1. 4 1 and 1 2, 4 1 and 1 1. So you can see 4 1 belongs to R2 and 1 2 belongs to R, and if we combine these two, we should write 4 2 in R3. Similarly, by combining these two, we will have to write 4 1 in R3. So 4 2 and 4 1, that I have to write here, ordered pair 4 2 and 4 1. Then I have to check for first component 2, and there is no ordered pair whose first component is 2. And finally again I have second component as 1, so I have already written those ordered pairs whose first components are 1 here. So I will combine these two ordered pairs with this ordered pair 1 1. 1 1 belongs to R2 and 1 2 belongs to R. Similarly 1 1 belongs to R2 and 1 1 belongs to R. So by combining these two, I will write ordered pair 1 2, and by combining these two, I will write ordered pair 1 1. So my last two ordered pairs are 1 2 and 1 1 in R3. So this is our third power of R. Now in the next step, I have to write fourth power of R, that is composition of R3 and R. R3 is this relation, so that I have copied here. This is R3, and here I have written relation R, that is this part. And again I have to obtain composition of R3 and R. So again same method, we have to check for each and every ordered pair of first relation, that is R3. Here second component is 2 and I have to search for 2 as first component, and there is no ordered pair whose first component is 2. Then I have ordered pair 3 1, so I have to search for those ordered pairs whose first components are 1. So there are 2 ordered pairs. So we can see 3 1 belongs to R3 and 1 2 belongs to R. I am taking these 2 ordered pairs. 3 1 belongs to R3, 1 2 belongs to R. Therefore I can say that 3 2 belongs to R3 composite R, that is nothing but R4. So corresponding to these 2 ordered pairs 3 1 and 1 2, I obtain ordered pair 3 2 in R4. Similarly, if I consider these 2 ordered pairs, 3 1 belongs to R3, this ordered pair, and 1 1 belongs to R. So this implies ordered pair 3 1 belongs to R3 composite R, that is R4. I am taking first component of this ordered pair and second component of this ordered pair. So what we obtain, ordered pair 3 2 and 3 1 in R4. So that I have written here. Next ordered pair is 4 2, but its second component is 2 and there is no ordered pair here having first component as 2. Then we have 4 1. So 4 1 has second component as 1, so that we can write here 4 1 belongs to R3 and 1 2 belongs to R. So we have 4 2 belongs to R4. Similarly, here also I can write 4 1 belongs to R3 and 1 1 belongs to R. So we have 4 1 belongs to R4. So I obtain 4 2 and 4 1. So that also I have written here. Here second component is 2. There is no ordered pair whose first component is 2. Then 1 1. So for 1 1 again I have 2 ordered pairs whose first components are 1. Here I write 1 1 belongs to R3 and 1 2 belongs to R. So I have 1 2 belongs to R4. And if I combine 1 1 and 1 1, I will obtain 1 1 itself. So again I obtain 2 ordered pairs 1 2 and 1 1. So this is R4. And if we compare these two sets, we can see all the elements are same, or these two sets are subsets of each other. You can see 3 2 is there, 3 1, 4 2 4 1, 1 2 and 1 1. So these two sets are exactly equal. So what we have obtained, R4 turns out to be R3. Fourth power of R is nothing but third power of R. R4 equal to R3. Now I have to write R5 also. R5 is R4 composition of R4 with composite R, or composition of R4 and R is R5. But R4 is nothing but R3. So I replace this R4 by R3, and R3 composite R is again R4. R3 composite R is nothing but R4 and R4 is R3. So R5 is also R3. R4 and R5 both are equal to R3, because R5 is composition of R4 and R, and R4 is nothing but R3, and R3 composite R is nothing but R3. So we have obtained required powers of this relation R. Here I have 5 elements, so I have to obtain I have to obtain up to fifth power of R. Okay, here I have written, I have to find out union of all these R, R2, R3, R4 and R5, and we have obtained powers of R up to 5. Now transitive closure of R is given by union of powers of R up to fifth order, and we can see these two are equal to R3. So I can write here one more step. This is union R3 R4 is also R3 and R5 is also R3. So this union is union of R3 with itself. So this is nothing but R3. So that I have written here. And I have to write down union of these three relations R, R2 and R3 that we have obtained here. We already have R 1, 2, 3, 4, 4, 5, 4, 1 and 1, 1. So that I have written here. Similarly R2 is obtained. So 3, 5, 3, 1, 4, 2, 4, 1, 1, 2, 1, 1. 6 ordered pairs. So that I have written from that step. And R3 is here. We have obtained R3 3, 2, 3, 1, 4, 2, 4, 1, 1, 2, 1, 1. And I have to write down union of all these three sets. So that I have written here. I have written 1, 2, 3, 4, 4, 5, 4, 1, 1, 1. Then 3, 5, 3, 1, 4, 2, 4, 1 is already there. 1, 2 is already there. 1, 1 is also there. Then 3, 2, 3, 1 is there. 4, 2, 4, 2 is also there. 4, 1, 1, 2 and 1, 1. So this is the transitive closure of given relation R. So this is very easy. You can easily find out the transitive closure of any relation. All you have to remember is, if your set has n elements, then transitive closure of relation R is given by union of powers of R up to nth power if a given set A has n elements. Here given set has 5 elements, therefore we have taken R plus equal to union up to 5th power of R. So this is all about this session. I hope you like it. Thanks for watching.